Okay, Teacher Think here, and I wanted to talk about science today because this is a subject that can be a little bit out of the control of parents at a certain point. Uh, the majority of parents really haven't thought about science in a long time, probably, and they just don't remember how the periodic table works and the specifics of it. I mean, they get the basic idea, but doing chemical equations or anything like that is just still a bit beyond them. So, especially high school chemistry or something like that. It's like that's just so gone. But that's true even for younger grades. But I'm talking today mostly about like when you're getting into writing real labs. So labs that are more than just a day of playing with stuff and having fun with science, but actually making a lab, doing an experiment, drawing conclusions, that sort of stuff. uh, as a tutor, I can tell you that the number one and two things, as you may know, I was a teacher for a long time, then a tutor. Number one and two things that teachers ask me for help with is math and science. And it's because both of them start to fade away for them. Reading's always going to be kind of something you can deal with, and maybe you want some extra help from somebody for certain reasons, whatever reasons. But at least you can pick up a book and read it, that kind of thing. Whereas something you look at the book, the science book or something, and it's just like you can't deal with it. Perfectly understandable. But there are things you can do to help your child with the science homework. And I'd like to go through a few of those today. And I'd like to contrast it with what you would say about English. Working with English versus working with science, because they're kind of vaguely the same, but they're really quite diametrically opposed in a lot of ways. And the number one thing is that in science, you have to be very thorough and actually kind of verbose. Like using more words doesn't matter. It's absolutely fine. So in English class, they're going to be saying, cut your words down, bring it down to the fewest words possible you can use to say your point succinctly and clearly and well, and less is generally better. Science, total opposite. You want to say more, always more. So if there's any comment that I see I could get back after doing a lab, it's going to be explain. It's going to be why. It's going to be say more about this. It's going to be what if you did the opposite of this. So this can be frustrating to students because they've put the answer. They've written down what the point is, and they don't really see where they have to say it three different ways. But you really do. You just have to be that thorough when you're doing science. Look at it from every angle, so that there's really no wiggle room for somebody who wants to disprove your thesis or whatever, or your hypothesis. Excuse me, because we'll get to those. Uh, so for even really obvious things like, well, we put a certain chemical in the test tube, and it heated up. And the teacher will be explain more, and you're saying, what do you mean explain more? So maybe they say, well, all right, we put this quantity of this chemical in, and it heated up. And it heated up by 11 degrees. And not just that, but it went from 70 degrees to 81 degrees Celsius. Okay, so you've got it covered. Still comes back saying explain. What do you mean by explain, teacher? Could you explain? Well, what happens if you don't put that chemical in? And it's like, well, obviously it doesn't do anything, but you have to rate it. I mean, even stuff that's that clear, you got to do this way and that way. So you will see if a teacher's breaking down like pre-lab, trying to help you get your thoughts together, they might say, uh, what happened when you applied pressure? What happened when you applied no pressure? What happened when you took pressure away? All three. You have to spell it out in full sentences, repeating a lot of the same information. And then you have to do that for each experiment. Sometimes I see that they're just cutting and pasting and putting things down. And then sometimes it gets down to something that doesn't really apply, and it's like, oops, but you just have to deal with that. So more is better, always more. If they're ever wondering what they can do, just keep writing, keep putting more, put more stuff, more detail, anything more that you can think of at all can only be better in science. The next big thing is that when you're writing, say, an English paper, you want things to be a little varied. You may have the thesis first or second or last even, or you vary your sentence structure. You try to make it interesting to read. You don't want to use the same word too many times in a row, so you don't want to use the word chased over and over again. You want to say followed maybe the next time or something like that. They don't like that kind of repetition. Something that sounds smooth. Okay, that's highly prized in an English paper. Science does not matter. It's just highly structured. That's all that matters. And you really want to be using the same words. If you mean the same thing, use the same word. If you're using the word stirred, keep saying stirred. Don't say stirred and then say mixed later on. They kind of mean two different things. So it may sound boring. It might bother an English teacher to look at the same word over and over again, but not a science teacher. They're going to want to see that consistency, and they're going to want to see something very, very structured. Same way each time, each paragraph, each lab. Next, you are working in an English paper to persuade. You're trying to come up with a good point that will be of interest to the reader and that will make the reader agree with you. In science, that's not really the point. You're really just looking at evidence, and you're looking at, and that's really it. I mean, you're just presenting the evidence, and you're going to draw a conclusion, but you're not trying to convince somebody of something that they, if you try to persuade, it sounds like you're trying to persuade them of something that isn't true. So you just have to be extremely factual and leave out any persuasive kind of argument. Like even things like, maybe as you can see, you can get away with, and consequently you might be able to get away with. But anything that seems to be pushing the writer one direction or the other will be viewed with a lot of suspicion. So, and science is just evidence. And the more evidence, the better. I mean, just don't hold back. If you've got anything to write for evidence, don't start cutting stuff out because it seems like it's too much. It's never too much. Next, the nature of writing an English paper is analysis. So you take a book and you break it down into its parts and see how they work together. I mean, that's a big part of what you do. And then with synthesis, you put them back together and with a thesis so that you've presented an idea and you've kind of weeded out some of the things that you don't need to make that argument. In science, really, 99.9% of it is really cause and effect. Cause and effect. We did this, that happened. Increase and decrease. If you're ever at a loss for words, use increased and decreased because things increase or decrease in science. And those are just the words you should use. You don't have to say gets better, gets more, rises, anything like that. Increases in height. Anything can be broken down into increase and decrease, pretty much. They like those words. And just always be sure to be outlining what caused what and keep it very specific. So, obviously when you're doing a lab, you only want to change one thing at a time so you can tell what the effect was. But that's really the name of the game. It's not an analysis so much as it's just a recounting of what happened and then what the evidence says caused what else to happen. Another thing that's a little bit more meta is that science is really discovery learning, and that is not always an appropriate method for teaching to do with discovery learning because it takes a long time. You can't sit kids down in a math class and expect them to eventually figure out how to multiply numbers, two-digit numbers together. It's not very realistic. And if they did, it would probably take them all year long to do just that. And it'd be very frustrating. And they may never do it. Never coming to a good conclusion, never doing it is fine in science. If you come to the end and you say, well, it didn't work, that's a valid conclusion. That's good. There's no problem with that. You can't do that in English. If you do that in English, then you had the wrong idea in the beginning. So you've got everything you need in English right there in your book if you're going to write a paper about it. I mean, you may draw on some other sources about what they say about it and cite them and all that kind of stuff. But basically, you're working with a defined amount of information. Whereas in the science, you're kind of taking a certain amount of information and seeing what happens when you fool around with it. There's no particular purpose behind what might or might not happen. There's no author there who's written this experiment for you, and there's no plot, you know. So if we applied this sort of discovery learning and this look at cause and effect to a book, say, then you would, and this is where we get into a hypothesis in science and a thesis statement in English. And let's just back up and go over those a little bit. Because in English, you want to have a topic, sentence, thesis statement. Then you back it up with the facts, and then you have a conclusion. And if you find that your facts are not backing up your thesis, you need to change your thesis statement. Okay? The other thing is, if you ask me anyway, you're making a big mistake if you start with a thesis statement in English and then try to find information to back that up. You really should start with the information and let the thesis develop out of it. Okay? Science, totally opposite. You come up with a hypothesis. You don't know if it's true or not. You see how that works, and at the end, you may be wrong. You may be right, you may be wrong, whatever. Or you may be probably right or partially right or whatever, and that's all that matters. It doesn't matter if you had the wrong hypothesis. That's good. It's all good. And that's something that can be very difficult for kids to really accept. It's like, so I was wrong. Well, sort of, yes. I mean, the hypothesis was wrong, but you discovered something that wasn't true, which is valid. I mean, think about Thomas Edison and the light bulb, right? So, I mean, if you applied that to a book, you would have a topic sentence, and then you'd go through and kind of laboriously look at every piece of information in the book, regardless of whether it really applied to it or not. And then you would finish it up by maybe saying, well, as it turns out, my topic sentence wasn't true. But what we can conclude is that the characters who got up early in the morning tended to get more stuff done. Okay, that would be a really bizarre English paper, and it wouldn't work that way. And you know what? I'm just seeing right here on my desktop something that's really, I'm kind of preparing it for something else actually, but this is your typical like English sandwich diagram for writing a paper. So up here, you put your topic sentence, and then you have details. These would be maybe 3 sentences, or they could be 3 paragraphs. Then you have your conclusion, and it's a little sandwich. And a science lab is similar in that you have a hypothesis up here, and you have a whole lot of discussion of your methods and what happened and what the causes and effects are, and then you conclude with what you can actually draw from that information and talk about whether your hypothesis was right or wrong. Now here's where this goes way wrong, because this is designed for an English paper. It says write your topic at the top, add details of the middle layers, add a concluding sentence at the bottom. Wrong way to do it. You should start in the middle and let your topic sentence develop. If you start with a topic, it may turn out to be wrong. You'll be tempted to sort of force that to be right. You will end up wasting time. It can be frustrating. But in science, you do that. You're taking a guess with that. The thesis statement in an English paper is to say what you're going to try to persuade the person of. And the hypothesis in a science paper is just to take a guess at something, and then you later see if it's right or wrong. That's all there is to it, you know. So that's just a mental leap. But you can help with all of those kinds of things. You can say, you know, keep writing, be verbose. Just make sure you're structured. Make sure you stick to evidence. Repeat things, even if it sounds useless to keep repeating them. That doesn't matter. Use the same word over and over again if it's the same meaning and if it refers to the same thing. You have to just get used to discovery learning. It's really tough, I think, for at least up until 7th or 8th grade. Most kids are not really ready to do too much cause and effect discovery learning. It's a real challenge for them. They just don't always make those connections. It's a huge leap, and that's just part of the challenge of that age group. Later on, high school, they can do that, but then it's just a matter of, you know, keeping good notes and all that kind of stuff. And, your hypothesis does not need to change in science. It's a guess. It's good if it's wrong. That's fine. Don't worry about it. So these are things that you can tell your student, your son or daughter about science, even if it's been kind of slipping away. And you can reassure them with that it's not an English paper. It doesn't have to be smooth, and it's not judged by the same criteria. So I hope that was helpful, and we will see you next time.